I hope all of you are doing good. Let's start today's chapter, Geometry. Number 1, look at the following object and write the name of the shape they resemble. Okay, this shape is a rectangle. Okay, and the shape of the coin is circle. This is square in shape and this shape is triangle. Right? Number 2, look at the following objects and write the name of the solid shape they resemble. This is sphere, cone, cuboid and cube. Okay, and in question number 3, you have to complete the pattern. Right? The word geometry is derived from Greek words geo means earth and metrins means measurement. Measurement of any shape or figures relates to geometry. In class 2, you have studied about 4 basic geometrical shapes, namely a rectangle, a square, a triangle and a circle. Let us recall plane figures. Plane figures are those that can be drawn on a flat surface such as blackboard, paper, etc. The adjacent figure shows a square. It has 4 corners and 4 sides. All its sides are equal. Okay, so these are the properties of square. The corners are also called vertices. Okay. Next, rectangle. The adjacent figure shows a rectangle. It has 4 sides and its opposite sides are of equal length. That means length of side WX is equals to length of a side ZY. Okay. WX and ZY both are equal in length. Okay. Similarly, length of side WZ, okay, is equals to length of side XY. Triangle. In the adjacent figure, PQR is a triangle. It has 3 sides and 3 vertices. Okay. Corners are also known as vertices. Circle. The adjacent figure is a circle. It has no edges and no vertex. It has one curved side. Right? Exercise 10.1. Number 1, in the following pictures, write R in the rectangles, S in squares, T in triangles and C in circles. Okay. This is very simple, you know. This is rectangle, so you will write R. This is circle, so you will write a C, and this is a triangle, so you will write T. Okay. Now, solid shapes. An object that occupies a space is called a solid. A cricket ball, a pencil, a brick, a playing dice are some of the examples of solid objects. Some solids have plane surfaces while some have curved surfaces. Some solids have both plane and curved surfaces. Cube. The adjacent figure shows a cube. It has 6 plane surfaces called faces, 12 edges and 8 vertices or corners. Each face is a square and 12 edges are of equal length, right? Next, cuboid. The adjacent figure is cuboid. It has 6 plane surfaces called faces, 12 edges and 8 vertices. Here the difference is each face is a rectangle. Okay. The difference between a cube and a cuboid is that in a cube all the 6 faces are identical, means same, but in a cuboid only opposite faces are identical. Okay. Cylinder. A cylinder has 3 faces, 2 faces are plane and 1 is curved. Okay. It has 2 curved edges and no corner. Sphere. The adjacent figure shows a sphere. It has only 1 curved face and no vertex and edges. Okay. Next, cone. The adjacent figure shows a cone. It has a 1 plane surface, which is this, okay. 1 curved surface, or you can say face, 1 curved edge and 1 vertex, right? Exercise 10.2. Name any 2 objects with only plane faces, okay. And number 2, name 2 objects with curved faces. You will do this exercise by yourself, okay. Point, line and ray. Number 1, point. A point, okay, this is a point, okay. A dot. A point doesn't have length or thickness. It simply shows a position. Let us look at a sheet of a paper closely. Its four sides meet at four corners. The length of the sides can be measured with a ruler, but we cannot measure the length of the corners. The corners are point, okay? See, these are the corners and these are the points. Can we measure the length of this point or corner? No, we cannot, okay? Line. A line has neither a beginning nor an end. It continues indefinitely on both sides. See, for example, this is a line XY. Okay, you can extend it indefinitely on both sides. You can extend this line from this side and from this side also. Okay. X and Y are 2 points on the line. The arrowheads on both sides show that the line continues on both sides. A line has only length and no thickness. The length of a line cannot be measured. Remember that. We cannot measure length of a line. Next is line segment. Line segment is a part of a line. Okay, the part of the line between P and Q is a line segment. It is called line segment PQ or okay. See, PQ. This is the symbol of line segment, and line symbol of line is, if we are representing a line, we will show two arrows. Okay. Okay. Now, since a line segment is not a line, it is a part of a line. It has a beginning and an end. We can measure its length with a ruler. Okay. So, because it has beginning and end as well, so we can measure its length. Okay. Next, curved lines. Lines which are not straight are called curved lines. Remember, only and only one straight line can pass through 2 points, but many curved lines can pass through 2 points. Okay. Exercise 10.3. Write true or false for the following statements. A line segment has a beginning and an end. True. We can measure a line segment with a ruler. Of course. Why? Because it has a beginning and an end. That's why we can measure it with a ruler. Okay, so the answer is true. Next, symmetry. In day-to-day life, we see that symmetry is in everything which are around us. The nature has plenty of things having symmetry in their shapes. The leaves, butterfly, human body, etc. The temples, mosques, gurudwaras and churches have symmetry. So we see that every object or figure has evenly balanced proportion. These types of objects are said to be symmetrical. Symmetry expresses the idea of balance. Okay, can you see these pictures? All these pictures are symmetrical. Okay. Line symmetry. The above shapes are equal in size on both sides of dotted line. That is, shapes are symmetrical about the dotted line. If we fold the figure about the dotted line, we could get two equal shapes which will overlap each other. So, the dotted line is the axis of symmetry. Here, these dotted lines are the axis of symmetry, or we can say that one half of the shape is a mirror image of the other half. If we consider that a mirror is kept along a dotted line, that is axis of symmetry, the image in the mirror would look exactly like the other half. For example, see, these capital letters of English alphabet, these are symmetrical about the dotted lines. Okay, dotted line means axis of symmetry, right? Next, see these pictures. This picture has one line of symmetry. Okay, H, it has two lines of symmetry. This figure has 4 lines of symmetry. It has 3 lines of symmetry, and it has no line of symmetry, right? Symmetry in the geometrical shapes of designs. Rectangle has 2 lines of symmetry. Okay, square has 4 lines of symmetry because it's all 4 sides are equal. Equilateral triangle. Equilateral triangle means a triangle which has 3 equal sides. Okay, it has 3 lines of symmetry. Isosceles triangle has 1 line of symmetry. Isosceles triangle means which have 2 sides equal, means opposite sides are equal. In isosceles triangle, opposite sides are equal and third side is unequal. So, it has 1 line of symmetry. And a scalene triangle has no line of symmetry. Why? Because no sides are equal to each other. Okay. Parallelogram has no line of symmetry. This is parallelogram. Okay, trapezium has one line of symmetry and circle has infinite lines of symmetry. Okay, symmetry in the geometrical shape of designs. Okay, now check this out. Vertical, horizontal, horizontal and horizontal. Okay, no line of symmetry, no, and this is a vertical line of symmetry. Okay, symmetry in the geometrical shapes of designs. Okay, 2, no, here no, again horizontal line of symmetry, no line of symmetry, no line of symmetry, 6, 7, no line of symmetry, and in 9 also no line of symmetry, and in 8 there is horizontal line of symmetry. Okay, now let's talk about patterns. Patterns exist in almost all fields of our life. Example, in music, architecture, art, nature, science and maths, etc. When something happens repeatedly again and again, one can say that a pattern exists. For example, pattern of sizes. See the pattern. Okay, can you see here the size of circle is decreasing or size of ball is decreasing. Okay, here also size of square is decreasing. Okay, pattern of numbers. Okay, as you can see, 0, 2, 4, 6, 8. Here we are adding 2 to every number and we are getting the next number. Patterns of letter like A, B, A, B, C, A, B, C, D, A, B, C, D, E. Okay, similarly this one. Patterns in even and odd numbers, even numbers. See, 2, 4, 6, 8, 10, 12, 4, 16. How these numbers are increasing? We are adding 2. 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10, 10 plus 2 is 12, 12 plus 2 is 14 and 14 plus 2 is 16. So starting from 2, each successive number can be obtained by adding 2 to the previous number. Such numbers are called even numbers. And odd numbers, you know odd numbers, these are the odd numbers 1, 3, 5, 7, 9, 11, 13, 15. Here also starting from 1, each successive number can be obtained by adding 2 to the previous number. Such numbers are called odd numbers. Okay. Patterns in blocks. See, you can see how these blocks are increasing. We have added 2 here, so we got 3, then we added 3 here, we got 6, then we added 4 here, then we got 10 blocks. Okay. Next, growing pattern. Observe the patterns given below and fill in the blanks identifying the rule. Okay. See how these arrows are growing or how these patterns are growing. Okay, 1, 2, 3. Now what will you get? And see vertical arrows. Now here 1 horizontal arrow, 2 horizontal arrow, 3, now 4 horizontal arrows. Okay. Next, 1 circle, 2 circle, 3 circle, 4 circle, 5 circle. Next, 6 circle. And this one, circle, triangle, circle. Circle, triangle, circle, triangle. Circle, triangle, circle, triangle, circle. Now, this pattern is growing actually. All these patterns are growing. Circle, triangle, circle, triangle, circle and triangle. So, all these patterns we notice that the pattern doesn't repeat itself but keeps on growing. These patterns grow according to some rule. Okay students, now you will do practice of this chapter by yourself.